Hi, my name is Sabrina Thompson. I'm an aerospace engineer at NASA Goddard in Greenbelt, Maryland. I design orbits and trajectories for space missions. I also develop technologies for spacecraft constellations, specifically small satellites. Actually, no. So when I was younger, I thought I would be either a basketball player or a famous artist. I still make art. However, I gave up the basketball days a long time ago. It was my art teacher who introduced me to mechanical engineering. I just love the courses. I love the challenge of solving problems. My first year was very difficult for me because I essentially was not academically prepared for college to keep up with my peers who had seen calculus before I did, and college level physics and things of that nature. But after my freshman year, every summer after that, I essentially did an internship. I did product development or product design work. I worked with industrial designers to design different types of products using like CAD systems. The next summer, I worked at a laboratory, Brookhaven National Laboratory in New York. I really liked the research environment, the R&D, like research and development. Another summer, I worked at Honda Manufacturing Corporation in Ohio. And that's when I learned I like working on complex systems. I put all those things that I liked about each internship together in grad school. I did an internship at NASA Glenn in Ohio. And that's when I knew I had to work at this place. I had all the schooling behind me, but I still needed to perform on the job training. So I did not know how to design orbits and trajectories until I started working at NASA. I understood math, I understood how to code, I understood science, and I understood how to solve problems. And so with those skills, it put me in a position to be able to then come to NASA and learn how to design orbits and trajectories. I actually come up with feasible orbit or trajectory designs for an upcoming mission or a concept for a mission. So I work very closely with the scientists. I work very closely with the propulsion engineers and some of the other engineers. I need to know what's the point, where we're trying to go. Let's say we're trying to go to Mars. Okay. So there have been some orbits and trajectories that have already been designed to go to Mars. So what's so special about what we will be doing? These are questions that I have to ask in order to come up with a feasible design. What type of propulsion system do we have? Are we using like an electric propulsion system, a chemical, all right? Because that determines how fast we can get there, or maybe some of the paths that we like. Just it matters for our options, basically. And is there a cost cap? How much money do we have for this mission? Because then that'll also have an effect on our options. I come up with a few designs that would actually work to get us, let's say in this case, to Mars. And sometimes we just want to do a flyby. Maybe sometimes we actually want to orbit. And sometimes we might want to drop off some small satellites. A lot of math. There's a lot of, dynamics. So you have to take all these things into consideration when you're designing an orbit, when you're designing a trajectory. So I developed that with a team of engineers a few years ago. The purpose of developing this technology was to be able to use things that we know, like, so for instance, stars, right? We know typically where stars are in relation to Earth. We also know, let's say, for instance, where the moon is in relation to the Earth. So if we use these systems together to then be able to figure out what the position is of a spacecraft system. So let's say you have a small satellite, we call it the mothership because maybe it has the equipment on board to be able to talk back to the Earth. But then we have another smaller satellite, or maybe the same size, but it only talks to the mothership. So if we have these two spacecraft that are talking to each other, how do we know the position of the non-mothership spacecraft in relation to the mothership and then in relation to the Earth. We use positions from stars that we know their position, and let's say some other celestial body like the moon. And we use all this information to be able to continuously track the position of both of these satellites in relation to each other. And that's just an example. There are lots of components. There's lots of different projects you can work on. So me and my team of engineers, we essentially wrote a proposal to do that work that allowed us to then get a US patent for developing this technology. There's this thing called TRL, or technology readiness levels. And so we were able to develop the technology to a certain level. We could possibly continue to do that and to develop it from a lower level to a higher level, or someone else can come in and do that. But the thing is, we need to have the money and the funding to do that. The other factor is that how we work as a government entity is that we develop technologies to fulfill the NASA mission, right? Which is to explore and to put information out there to the public about Earth in our universe, and to develop technologies that could then be used for applications that are beyond what we intended it for. At the moment, I'm not doing anything else with that technology as far as developing it. I've moved on to other components related to satellite constellations. So now I'm looking at using autonomous systems to be able to have the spacecraft and the constellation talk to each other and maneuver relative to each other to take some science data that maybe we can't do with one spacecraft. As of like August of last year, I completed a graduate degree in atmospheric physics. There was a gentleman who unfortunately passed away a few years ago, Dr. Pierce Sellers. He was an astronaut, and he also was the director of the Earth Science Division at NASA Goddard. And he was my mentor. Shadowing him one day kind of changed my path a bit. I thought to myself, I don't want to just design orbits and trajectories. I want to know more about this climate change issue. He suggested I go back to school and learn the science, and that's what I did. At the moment, there's a future mission concept that we're looking at for Earth science, where we could use a constellation of satellites to learn more about climate change, clouds, aerosols. Aerosols are like dust particles, pollution, all the things that could really alter clouds, alter the climate, alter the oceans. I wrote a paper with a few scientists looking at a combination of orbits with a certain instrument on it called a polarimeter, which would allow us to answer questions related to how these clouds and aerosols interact and how that might affect the climate. Another project that I worked on, which is also Earth science related, is a mission which will be launching here in 2024. It's called PACE, and PACE is basically a mission that will help us answer questions related to our oceans. We have different ocean colors, but it's why. And a lot of it boils down to the phytoplankton, algae, and like different algae blooms. How is that affecting us? How is that affecting everything in the ocean? Again, how's that affecting the climate? So it's a lot of these Earth science related questions that for me are very important because this is home for us. It was more exciting, I would say, when I was able to actually go to work physically. The NASA center I work at, you could find someone coming to work in flip-flops and a Hawaiian t-shirt. You could meet up with colleagues and discuss things, solve problems. There are also lots of seminars that go on throughout the week. So there's always opportunities to learn outside of whatever projects you're working on and to collaborate with people. So a typical day, I could ride my bike into work or I could drive in. It's a very friendly environment. There's lots of sharing of information. So if I'm stuck on a problem, I could just walk down the hallway to like one of the flight dynamics gurus and ask them, they've probably seen a problem like this before and solved it a million times. A lot of my work is done on the computer. So sometimes I can put my headphones on or my ear pods or whatever, and I could just zone out and sit there for lengths of time and just design orbits. Sometimes I need to be in meetings where I need to talk with scientists, with some of the other engineers. I'm a very curious person. So I'll just go in somebody's office, and if they talk to me, which most of the time they do, about what their work is, it's always opportunities to learn. So I network a lot at work, and that's how I get on certain projects. These days, I'm at home working. Sometimes I go to coffee shops and I can do work if I want to change my surroundings. But we're slowly getting back to the office. The biggest thing that has helped me is being open-minded and being really open to learn from others and collaborate with others. My form of communication that works best for me is visual. And you probably guessed, because I'm an artist. So I can draw anything, honestly. Some people are better with their words. Some people are better with just looking at numbers or reading things. Definitely be prepared to be a team player. Definitely be prepared to have fun solving problems, because that's what this is all about. It's solving problems to really understand our environment and, of course, the universe. Be curious, right? Ask questions. There's no such thing as a dumb question. Definitely think outside of the box. Just because we did it one way for the past 20, 30 years, that does not mean that we have to continue doing it that way, whether it's solving problems or approaching problems. You could be the one that develops a new technology that allows us to live life or perform research or look at data in a completely different way. So I would say definitely do not limit yourself. I'm one of these people, I get bored a lot if I know how to solve the problem, or I solve the problem so many different times. So for me, it's very important to continue to learn. NASA allows you to do that. There are so many things that we don't know about. I just mentioned Earth, right? It's a lifelong learning kind of experience here at NASA. And that's something I really enjoy. So it never gets old, it never gets boring, because there's always new problems to solve. There's always new things to explore. My colleagues, these are people who love what they do. And a lot of times honestly, for some people, they probably wouldn't even have to get paid to do their job. They love it so much. And so when you're working with people like that, it's easy to kind of have that spirit, if you will, rub off on you. And it also allows for a happy workplace. So that's something I really, really like about working at NASA, and NASA Goddard specifically. I think what keeps me going is that there's so many unanswered questions. And I think it's critical for us to continue to push forward as far as our understanding of our universe. We're talking about going to Mars, setting up a habitat on the moon, having the moon be like a pit stop on the way to Mars. That's insane. The technology that has to be developed for us to get there, right? The communications aspect, how are we going to communicate back home? Different systems that need to be set up, right? How are we going to survive on Mars? All these things that we have to think about. And that's just a piece of it. That's just one part of exploring our universe. And so I just think so it can be a lifetime, many lifetimes of research, development, and exploration that can be afforded at a place like NASA. I don't have the pressures to perform at the same level as somebody who works in the private sector, because it's not about making money. It's about our understanding of our universe. I think I'm most proud of getting back into being a creative person. I put a lot of time into developing myself as an engineer, but I've always naturally been an artist and a creative person. I found a way to blend those two worlds. I have a company I developed called Launchpad. I develop STEM-based services and products, clothing, art, like you see behind me, as well as programs like my Stimulating Art program, where I teach kids STEM concepts through art projects. And so it's my way of giving back, but it's also my way of really inspiring the next generation to go beyond, do more than somebody like myself has done, to really just, again, inspire them to go after their dreams.